Okay, so what we're going to do is we're going to finish the muscular section on here, and future ones. I know right now for this um, particular pilot program, I'm having to do these in multiple different sections. But when we actually do the full program, if we get this approved, these will be recorded basically on 50-minute to hour plus sections. They'll be in one section. So I'll get your feedback of what you think as well for future. Okay, so muscle mechanics. Here, basically, we're talking about how we get the muscle to move and how we basically are able to use our body the way we are. So, whether that's doing fine motor motions and we're using a lot of different muscles to come in and get fine organization, as with our fingers and hands and fine motion here. Here's my hand right there. Fine motion particular. This is weird doing this. Fun for you, huh? All right. So versus we're doing big lifting and we are using different muscles. So we apply tension basically to an object. That's grabbing it, being able to pull it, lift it, and then we have some kind of resistance or opposite force. That's basically our weight or shape. Um, and basically, how we produce tension is getting those muscle fibers to contract. It basically just grabs, they get all those shortening, we get those motions in there, and we have different muscle fibers. As we know, we have our biceps and our triceps are working opposite of each other. Those are the type of different things that we do to basically move our arms. So as our bicep contracts, our triceps relax. Vice versa, when we contract our triceps, our biceps will tend to relax more and lengthen because those muscles are working opposite each other. And then we basically have to do stimulation to get those muscles to go and get them to react, and that's how we do the nerve stimulation. So here's basically a simple twitch. This is just to get the muscle to move. And what we do is we have this resting phase, or basically is the muscle sitting still. We get the stimulation or that nerve impulse that releases acetylcholine into the cycle, opens the channel for sodium to get into the sarcoplasmic reticulum area, which causes the release of calcium and does that whole phase we just talked about. There, once that occurs, now we get contraction of the muscle, and we can develop all sorts of tension depending on where we want. At the first initial release, we want to get back some tension, but maybe we just want to lift a little bit. We're not lifting something small versus heavy. Maybe we'll get different ways of that contraction phase. Once we've done that motion, then we're going to relax, and then those areas are going to calm back down. We're going to release calcium back in the sarcoplasmic reticulum. The whole system is going to reverse, and the muscle is going to relax. That's kind of the phase that we go through with this muscle. So as that goes through here, that's kind of what we're looking to do. So there's a couple different stages that we go to. Our latent period, which is basically kind of getting everything all set to get that action potential to move across. There's the actual stimulation and that contraction phase where we get that tension to going on there. We'll get that muscle stimulated, then it needs to relax. It falls back to resting potentials. The calcium drops in there, and then we're basically ready for another stimulation of another fiber. So that's kind of the area. The other thing we do is basically as we're lifting, we may find multiple stimulations that we do. As we increase stimulation, we get more and more of a contraction. So obviously we're going to go heavier, we're going to go longer, we're going to stimulate much more to recruit more muscles to lift in as we're lifting heavier objects or as we're lifting into positions. We're starting from the ground and we're lifting up above our head. We're going to recruit different muscles that are going to come in and help us with that. Vice versa, if we're going to pick something up into a position, basically we're going to pick up a vent fan and we're going to carry it a distance. Well, we're going to recruit our muscles to get it up to an area where we can carry it. Now we're going to maintain those muscles in a certain spot so we can walk forward with it, and we're going to maintain. We're not lifting up or down any further, but we want to maintain that area. And so that's how we're going to bring muscles and recruit in. The other aspect is so you're doing a hanging from a bar, doing chin-ups and such. And now you're basically recruiting all your muscles to hold up, and now you're holding on that bar. And you're holding as long as you can, and then you run out of energy. You run out of oxygen to the muscles, and the ATP, which is our way we get injury, drops off. It drops off. Now the muscles can no longer go. They cannot hold, and you just have to come down and release because they can no longer hold you in those spots. So those are different aspects, and we'll talk about how we build that and how we get muscle. But that's basically when the muscle hits that complete tetanus, and then once that happens, the sarcoplasmic reticulum does not have enough time to get those calcium ions back in that high concentration, and basically it keeps contracting until there's nothing left, and then it gives and it has to collapse because there's no more energy to keep that up. So again, the stimulation comes from our body and how we, sorry, I'm adjusting the screen, how we move that muscle. Again, our skeletal muscles is our voluntary muscles, or we basically control those. So from our spinal cord out is going to tell us where our muscle's going. I'm going to talk about neuro of our ventral and dorsal aspects and what's motor and what's sensory, but this is going to come up, and these are motor nerves coming out of the dorsal aspect, going down to the muscle, and this is what's going to go out to all these different areas, and how many nerves innervating the muscle depends on the muscle itself. Whether it's a back muscle and we only need 1 or 2 nerves, or whether, like I said, it's muscles in the hands and fingers that we need maybe 12 to 13 nerves for that fine motor sensation. And that's how we're going to get that signal down. And that's going to talk about recruiting, getting them in, staying muscles toned, getting our peak tension, which basically is holding it and holds a contraction, a sustained contraction, and that's basically like the walking motion on there, keeping our muscle tone, so we're obviously always contracting, resting, and building up that muscle tone so we don't get atrophy, keeping our resting muscles toned and stabilized so they're positions, because even when our muscles are relaxed, there is a little muscle tone. We need to have that, because if we don't, and we allow the muscles to not be motion, or if you have an injury and you're in a cast for a long time and those muscles aren't really being utilized, they can atrophy, or basically they can become smaller and weaker. For most areas, depending on the time, they are reversible. You can build them back up. If you have a extreme loss for a long period of time, you can atrophy the muscle, and some fibers cannot be replaced or rebuilt, but in most cases you are able to rebuild that. Lots of different kind of disc contractions. We have our isotonic and isometric, and again, these are basically examples of getting an area and not necessarily contracting or relaxing the muscle, but just maintaining those positions, as you know. So I'm not going to go over too much of those. You guys should know that area, but basically we have to get the muscle to be able to move and walk. And basically our forces that we occur from this is our elastic forces. Basically anytime we contract, they're going to want to bring it back into an area and stretch. The movements of the opposite muscle, so when we contract our bicep, we are pulling our tricep back to elongating it. And then gravity, as we just let our arm rest down to the ground, it's going to pull things out too. So different things that are going to affect our muscles and how our contraction goes. So now the next aspect that we deal about is, how do we get this muscular activity? You know, what gives us the ability to move? And this is ATP. ATP is our energy source. That's for our entire body of how it goes. And ATP, adenosine triphosphate. It's an adenosine molecule that has 3 phosphates off it. And basically, to build, it takes energy to build a phosphate bond. So we build up these stores or energy stores in ATPs by putting energy. When you break that bond, it releases energy. So what'll happen is, and I'm kind of just jumping up here, is we have ATP, and when we break down this bond and make it ADP, adenosine diphosphate, that releases energy that the body utilizes to make its motions, movement, brain functions, whatever it needs to do. So we're basically that transfer in energy, and creatine phosphate is the other component of this that we're going to go over and talk about how it's utilized. Those are going to be our main functions. So let's talk about adenosine triphosphate and creatine phosphate. So what we have is we have the blood vessels. This is what brings us all our nutrients, our fatty acids, our oxygen, and glucose. Those go into the muscle itself. Now, glucose is stored as our muscle store as glycogen. So to convert glucose into glycogen, we need to break off some energy. So it takes ATP breaking off that bond to convert glucose to glycogen. Now we're storing it. It's basically, here's the electricity coming in. We take a piece off so we can store this, and this is like a battery pack for our muscles. Glycogen is battery pack for our muscles. So we store that here. Vice versa, if we were to break glycogen down to glucose, we will get that energy store back. Just reverse this arrow. So we're basically taking this energy, storing it into this battery called glycogen, and then when we break down glycogen, it reduces back to glucose and releases our store. Our mitochondria, and this is basically anaerobic. So this is done without any oxygen needs. Now, in our mitochondria within our muscles, this is where it uses oxygen. This creates a lot of ATP. So aerobic respiration and area is basically going to produce a lot of energy, and that's why we have to keep up our respiratory function. And when we can't breathe and we're tired and we can't get any more oxygen, then we aren't producing our ATP and we get tired. Other aspects we need for building muscles is creatine. We talk about creatine supplements and all those when we lift and that, but creatine also uses energies to store as creatine phosphate. Creatine phosphate is another type of battery, if you will, and it's a way that we're storing energy within the muscle itself. So these are our two main stores that we're able to use anaerobically. So this is what our muscle stores in here. And I love pictures to talk about things, so I'm going to continue using these and kind of going over. So again, here's our normal area. That's our resting muscle. And as we're resting, we're basically using little bits of energy, but we're able to store up this energy as our body eats, and we're building up our stores, and that's where we go. So this is our aerobic metabolism. Here is now we're getting the muscle to contract. So here we need to actually use up some of those energies. So what'll happen is that glycogen store, that battery pack we talked about, we need to convert it to glucose. So when we do that, to break down that energy, that releases some energy to us. So it breaks us down to the glucose. The glucose releases 2 ATPs, or basically it gives us 2 forms of energy that comes into this. When that happens, we're using that glucose in there. It gives us that energy, and there's our energy to contract the muscles. Problem is then that leaves us with pyruvic acid. Pyruvic acid, when we have good oxygenation, is a fantastic thing because it comes down into the mitochondria. The mitochondria, as long as it has fatty acids and blood supply and oxygen, can produce 34 ATP. So just the glycogen stores gets us about 2 ATPs. Pyruvic acid into this is what's called the Krebs cycle, I'm not going to go into, gets us 34. So you can see the better our oxygen breathing capacity is, and this is why we stay in good shape, because it gets us more energy and we can sustain much longer, where without that we can't last as long. So that gives us a lot of energy here. The problem comes in is if we do not have that oxygen ability, we're not getting oxygen to the blood because we're not in good shape, we're just getting back into shape, or we're big bodybuilders and we don't have a lot of respiratory area, and so we're moving a lot. We don't have that. We're only getting those 2 ATPs. We also are breaking down that creatine phosphate into creatine. That's only getting us 1 ATP. So we're getting about 3 ATPs, not very much. That pyruvic acid now that we're producing from breaking down the glucose, now we don't have any oxygen to convert more ATP. So that basically gets broken into a free radical called lactic acid. Lactic acid gets secreted out into the blood as our waste products. And we all know if we have high lactic acid, that causes our pain and soreness afterwards. Our body breaks down. So that's why after a hard workout, we're sore, and that's that lactic acid buildup. So again, it's a waste product our body has to take care of. So you can see a big difference. Without oxygen, we can produce 3 ATP. With oxygen, we can not only produce our